Today we're going to be covering quantum fluctuations, but a explain it like I'm five version, because I don't have a PhD in this. I definitely don't know anything about this, and I want to, so we're going to learn about it together. Let's jump into the world that's smaller than atoms. All right, let's start with the basics. What is quantum fluctuation? In the very simple terms, it's this weird phenomenon that happens at the tiniest level in our universe, the level that is smaller than atoms, the quantum level. It deals with super tiny particles that make up atoms. I remember in school learning about atoms being the smallest particle in the universe, and we're now discovering that that is not the case. Even though we imagine space as being completely empty, like from me to you right now, it seems like it's empty, but it's absolutely jam-packed with energy. It turns out nothing is totally empty, even in what we think of as nothingness. There's actually a lot happening in the nothingness. Quantum fluctuations are tiny random changes in energy that constantly happen in these so-called empty spaces. Particles pop in and out of existence even though we can't see it, and this fluctuation is constantly at work. We're gonna get some imagery for this, okay? So imagine you're standing in your living room. It's an empty room. You don't have any furniture in there, you don't have anything. And to you, it looks empty, but there are actually super tiny little creatures that are popping in and out. They're kind of blipping in and out of existence, but it's so fast that you don't actually see it. That's kind of like what's happening with particles in quantum fluctuations. We think space is empty, but it's filled with energy and activity. We just can't see it. Now, if space is empty, where does energy come from? I thought that energy couldn't be created or destroyed. I thought it could only be transferred. If there is all of this energy in nothingness, then where does the energy come from? The answer lies in something called 0-point energy. 0-point energy is the lowest amount of energy that exists in the universe, and it's everywhere, even in a vacuum, which is usually what we think of as literally nothing. The kicker about this, though, is that the strange laws of quantum mechanics, even when there's no matter around, there's still energy in that empty space. The energy is constantly shifting and changing, and it allows the particles to borrow some energy, briefly exist, and then vanish again and cease to exist. It's super hard to understand, but basically, as they come and go, they share that energy of one another, which allows them to exist momentarily. Think of it like these particles are renting the energy from the universe just for a moment, and then they give it back when they disappear. We're going to look now at Heisenberg's uncertainty principle, not Breaking Bad Heisenberg, but I like where your mind's at. So how do these particles just pop in and out of existence? The answer to how these particles just pop in and out of existence is one of the key ideas of quantum mechanics called the Heisenberg uncertainty principle. The principle says that you can never know everything about a particle at the same time. In particular, you can't know both its position and its speed exactly. The more you know about one, the less you know about another. The uncertainty is what allows quantum fluctuations to happen in the first place. Since we don't know exactly what's going on at the quantum level, particles can behave unpredictably to us. They can disappear, reappear, and fluctuate in energy without breaking the rules of physics. It's like the universe is constantly allowing these particles to do these little wiggles without us knowing exactly when or what they're doing, or to be able to predict the next wiggle. A very simple analogy is, imagine if you could borrow money from the bank, spend it, and then give it back so fast that nobody even noticed. Quantum particles do something similar to that. They can borrow the energy, pop into existence, and then disappear so quickly that it doesn't violate any of the natural known laws of nature. That's how they're little sneaky bastards. Now we're going to get into some of the ideas about why quantum fluctuations are so important to us and the universe, and how they may have shaped the entire universe itself. Scientists believe that quantum fluctuations played a huge role in the early moments of the universe right after the Big Bang. In those first tiny fractions of a second, the universe was incredibly small and incredibly hot. Conditions where quantum effects dominated. Because of quantum fluctuations, these tiny ripples of energy started forming in the universe. These ripples were basically random variations in the energy of space. But as the universe expanded and started to cool down, these tiny ripples got stretched out and magnified. Over time, they became the seeds for the galaxy, stars, and all the planets that we see today. Again, this is all insane. This is crazy, but super fascinating. Think of it like this. Imagine you're baking a cake and you add a little sprinkle of cocoa powder. At first, it's just a tiny sprinkle, barely noticeable. But as you stir the batter and it rises, that sprinkle spreads out and mixes into the whole cake. In that same way, those tiny fluctuations in the early universe stretched out and became much larger, eventually forming the structure of the universe. But wait, there's more. Quantum fluctuations might also be connected to one of the biggest mysteries in the universe: dark matter, or dark energy. Dark energy is this invisible force that makes up about 70% of our universe, and it's responsible for the accelerated expansion of the universe. Some physicists think that those little random quantum fluctuations happening in empty space could be the source of this dark energy. Because these fluctuations constantly add energy to the space, they might be responsible for pushing the universe to expand faster and faster. This is all still just a theory, but it shows that these tiny quantum effects might have massive consequences. Essentially, because it's constantly happening, they are creating this dark energy with their instantaneous appearance and disappearance, and that dark energy is responsible for the expansion of our universe. Super insane. Kind of explains how it's essentially infinite. Space is infinite. Maybe it isn't, but it's growing so large and so fast that it's infinite to us because we'll never reach the end of it. It's always going to be so far ahead of us, so quickly growing that maybe it will eventually be infinite. Maybe it's not infinite now or yet, but what is infinite? It's breaking my brain. It's crazy to think that it's so large that it kind of doesn't exist, or does it? I think I broke my brain. We're not even done yet either. Let's get locked in because we're still going. Another super interesting effect of quantum fluctuations is something called virtual particles. Remember that word. Remember all this. Try to remember all this. These are particles that pop into existence and then annihilate each other almost instantly. So they never really become real particles that we can actually observe. But even though we can't directly see these virtual particles, they still affect the universe in important ways. For example, virtual particles can create a force called the Casimir effect, where two uncharged metal plates can actually attract each other because of the pressure created by quantum fluctuations between them. So it's like magnets, except without being charged. Because a magnet is a charged piece, one is charged, one is negatively charged, so that's what pulls them together. These are two completely uncharged pieces of metal, but the Casimir effect is still pulling them together. It's like the vacuum of the universe has a hidden magnetism power. Imagine you have two flat plates floating in space. Just floating around really close together. Even though they're in a vacuum with no air, nothing, they can actually feel a tiny force pulling them together thanks to these quantum fluctuations and the vertical particles between them. It's an example of how these seemingly tiny effects can have real-world impacts even on the human scale. So, why should we care about any of this? Well, quantum fluctuations are more than just a weird quirk of the universe. They're part of the fundamental building blocks and fabric of the universe. They affect how particles behave. They could explain dark energy and the expansion infinitely of our universe, and they might even set the stage for the formation of galaxies and stars after the Big Bang. Understanding quantum fluctuations helps scientists understand the rules that govern everything in the universe, from the smallest particles to the largest of galaxies. So, in summary, quantum fluctuations are random, tiny changes in energy that happen at the quantum level, smaller than atoms, even in what seems like completely empty space. Again, like between you and me. They're the result of quantum uncertainty and zero-point energy, and they could be one of the keys to understanding our universe from its earliest instant moment to its possible future. My mind is blown. I also feel like this is just so much. It's so much. I can't even imagine a single atom. It's just so tiny to comprehend. Just the particles that are sucked together, and then those are sucked together, and enough of a certain one and less of another one turns it into a certain element, and more of those put together turns it into everything around us. And it's the fact that it gets any smaller than that is crazy. The fact it's so much. It's crazy. The fact that we are so small in this universe, our existence is insanely minuscule, I guess, but there's something really humbling about that. But the universe is teeming with life down to the mega microscopic level. There are things in play that are much bigger than us. It's really cool to think about. It's really humbling. I like stuff like that. But thank you guys so much for watching. Hopefully your brain isn't oozing out of your ears right now. Hopefully you learned something. I think I learned something today. And I don't even know what to title this video, but thank you so much for watching. I appreciate it. Say thank you to Alexa. Drink lots of water, and I will see you next time.